Really pleased to be here today, and I was very glad to get this invitation to come and tell you a little bit about the Academy, but really to give you a bit of the context of the issues that are behind the Academy and driving our agenda. I'm particularly pleased to be talking to people who are doing a PhD because I think that is one of the most marvellous opportunities you will get in your lifetime to be able to make a personal contribution to an academic subject and to be able to push forward the boundaries of human knowledge. So having said that, what actually happens to you after you get your PhD? I've taken this slide from a Royal Society report which was published a couple of months ago called The Century of Science. It talks about what happens to people who've done their PhD, and this is a science PhD, so it might be a chemist, a biologist, a physicist, or a computer scientist. I've no reason to suppose these statistics aren't as valid for computer scientists as they are for physicists. So on this side, we have the people who have just finished their PhD. And over here along this horizontal axis, we have people moving through the academic career structure until they reach the ultimate goal of becoming a professor. And what you can see is that 0.45% of people who finish a PhD will become a professor. Yes, that is usually a surprise to people. If you go back a bit and look at people who manage to stay in the academic world as a permanent member of staff in some form or other, so that might be as a permanent researcher or as a university lecturer, we're still talking about 3.5% of all of the people who finish a PhD. So in fact, I think there were meant to be about 20 people here today, so out of those 20 people, one of them would have made it to be a professor. What happens to all of the rest of you then? Well, you end up working outside in business or government, but essentially not in a university. You might be in research still, not in a university, or you might be becoming a captain of industry, you know, an entrepreneur, starting companies, running Tesco's perhaps, I don't know. So that's a little bit of background for you to think about while we have the rest of the slides. So the BCS Academy of Computing, what's that about? I think it's widely recognised that there is a gap between academia and the professions, and also a gap between what goes on with professions and academics and what happens at school. So one of the main ideas for the Academy is to bring together all of those groups so that they can talk to each other, but not just talk at each other, but work with each other to actually address the problems that are there in society and which are hindering the UK especially in terms of what happens in IT and computing. And computing is the most important thing as far as the Academy is concerned, hence the name Academy of Computing. Actually, I'll go back to that previous slide for 1 second. There are, in the UK, very well established bodies for people who are professors of computing, I'll mention a couple in a moment, or people who are internationally renowned researchers, these guys. There is no body in the UK that specifically looks at computing as an academic discipline for all of these other people out here who've done their PhD and are not going to end up there. And that group is one that we specifically want to attract into the Academy within the BCS. Okay. So, who are the BCS Academy? Well, not surprisingly, it's the BCS. But we also have two other founding partners, CPHC and UK CRC. Have any of you actually heard of CPHC? Ooh, 1, 2. Anybody heard of UK CRC? 1. Very good. Okay, so this is what it says here. It's the Council for Professors and Heads of Computing. It's the subject body. So each particular academic discipline has a subject body, so that is the senior professors for that particular subject from all of the various different universities. So there's one for electronics, there's one for mathematics, there's one for physics, and so on and so on. So CPHC, it is the professors essentially across the UK academic community. That's been around for a very, very long time. UK CRC represents people who are, I suppose you would intuitively think of them as the elite researchers within the computing community. So certainly it represents people from research-intensive universities, but it also represents people from research labs in industry. So for example, Andrew Herbert, who's the Managing Director of Microsoft Research, is a member of UK CRC, just to give you one example. So if we go back 20 years, I think it's fairly safe to say, or reasonable to say, that there was a certain amount of friction between these two different bodies because they saw the world in rather different terms. As the years have progressed, they have become closer and closer to each other. And what's very, very good now is that they are officially founding the BCS Academy of Computing with the BCS. So it shows that we are getting a much more cohesive approach to what's going on in the computing community amongst those two different senior bodies for academics, as well as the professional body, which is the BCS. Having mentioned Andrew Herbert, we have a jolly nice quote from him about the founding of the Academy of Computing. I'm not going to read it out to you. I assume we'll be circulating the slides later on so you can read those for yourself. But what he basically says is, it's a jolly good thing, and he thinks it's great. He also mentions in his quote 3 areas which are areas of concern which define issues that the Academy will be looking at. And to summarise them, the difficulty of what goes on in schools as far as computing education is concerned, the problems for university departments, which are suffering a lot in the current economic climate, and the fact that there is a gap between business and academia, which somebody needs to do something to bring those two different communities together. To give you a quote from another very, very senior person, Dame Professor Wendy Hall, who's at Southampton University. She's a member of CPHC, UKCRC, and the BCS. She's currently the president of ACM, which is the Association for Computing Machinery. It's kind of the American equivalent of BCS, but with a much more academic slant than the business slant. And again, this is somebody very senior saying that it's great that CPHC and UKCRC are able to come together with the BCS to found the Academy of Computing. So one of the key areas that the Academy is going to try and address as it gets going, and it is only just starting to get going. We've only formally existed since October of last year. So right now we are still putting together people on different committees that will look at different aspects of what we need to think about in the Academy. But one of the key areas that we need to address is this gap between universities and business. And for you doing a PhD, this is an area where you will have a role to play, because as we showed on that first slide, one person from this room is probably going to become a professor. Possibly 2 or 3 will stay on as permanent academics. Some of you already are permanent academics. And the rest of you are going to go out there into that wider business community and influence them about what they do with information technology and computing. So, lots of stats on some slides to come about the sort of situation we're in at the moment. EPSRC, the Engineering and Physical Sciences Research Council, have about, I think it's about £70 million a year that they give to universities to do research. In 2004, they did a survey of industrial collaborators that work with the universities on those various different projects. So they talked to, I think it was about 3,000 individuals. And they repeated that survey in 2008, and they pretty much talked to the same individuals. It wasn't quite the same group, but it was very nearly the same group. What they wanted to do was find out what are the benefits of interacting with universities from a business perspective, and what are the barriers of working with universities from a business perspective. Through the survey, they extracted a whole list of categories of things that the businesses said were good about working with universities. I'm not going to talk you through all of them. There's a load of them, and they ranked them. They gave them a score, and there you go. There's the result from 2004. Okay, fine. What's interesting is when they repeated that survey in 2008, keeping the same category of benefits that were identified, and ranked them again. Most of them, the majority of them, were perceived to be as of less value than they had been in 2004. And in fact, there's only 3 of those categories where there's been some improvement. And the ones that were improved were essentially things to do with employing people and short-term benefits in terms of getting an advantage over a competitor. Okay, interesting. Let's look at the barriers then. So, again, these different categories were the ones that were identified by people in the survey. And there's a whole load of barriers. And then they asked the same question again in 2008. And every single one of the barriers had perceived it to become worse. And what really interests me is the first one. A barrier to working with a university is the fact that a university does long-term research. Well, to my mind, that's precisely what a university should be doing. Okay, and in 2004, 31% of the collaborators said, yep, that's a problem. 2008, that's doubled. 65 and a bit percent said, yep, long-term research is a problem. So we're in a situation where over a 4-year period, every single barrier, as far as those industrial collaborators are concerned, has perceived to get worse. What else do we know? I've got a graph here that I've taken from a paper from Alan Hughes and other people who wrote this back in 2005. And they did a survey of, I think it was about 1,000 companies. So this was companies as opposed to individuals. And they asked them, okay, when you're producing some new technology, who do you talk to? Where do you find out what you need to know? So what are the sources of knowledge that you're going to use? And then they ranked those sources of knowledge according to what the company said about them. So the most important source of knowledge for a company is internal knowledge, not too surprising. And then comes knowledge that they can find from talking to their clients or customers. And so on 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 and so on. And then we get to the universities, which are fourth from the bottom of this list, which is interesting. So I've got some other facts here taken from another paper which I've referenced at the bottom. If you look back to prior to the internet bubble, leading up to the internet bubble back in 2000, 2001, and you say, what was one of the companies that had the biggest influence on economic growth in the States? And if I hadn't shown you this slide in advance, you'd probably say, oh, it's Microsoft, or oh, it's Google, or whatever. No, it was Walmart. And why? Because they were able to transform the way they behaved as a business through the use of ICT. Microsoft certainly massively contributed to the capacity of Walmart to achieve that, but Microsoft itself, although they do have, it's believed, a very, very large cash pile sitting somewhere, that didn't actually change the entire US economy. It was people like Walmart who changed the entire US economy. So if you want to affect transformation in the business world and the economy, yes, the IT technology companies like Microsoft, Google, etc. are important as enablers, but the people who actually do the transformation are the people like Walmart. Another little fact that's interesting for people who work in universities, a lot of the time governments will say that you need to invest more heavily in start-up companies or spin-off companies. Yes, they're very important, but let's consider what really goes on if we look at the facts going back to 2004 in the US. Apparently there were 462 startups which were based on technology, so IP means intellectual property there. That's out of about 500,000 startups in the US. And a lovely quote that I'm giving here from this paper from Alan Hughes. The vast majority of productivity growth experienced in any economy and in any industry and in any time period is due to the transformation in productivity from established companies. So what happens? What happens is spin-offs and new companies tend to start up with bright new ideas which are very exciting, and established companies that are good established companies tend to pick up those ideas and use them internally to transform their own business. And as a result, the spin-offs and the startups often then die out because the existing companies with traction and the infrastructure then just take over in that particular area. But there are exceptions, of course, which is where there are new technologies and where the cost of entry in those new industrial areas are low, which is why Google got there. So startups are very important, but again in terms of having a serious material effect on an economy, it's the established companies that are good at transforming the way they do business that make the real difference. So what's going on in the software world? Where are we going to be going in the next few years? I've taken some statistics here from a Forrester research report. There's a massive data on here, but the interesting bit are these red curves. So what's this showing? This is a forecast, and therefore it may be completely wrong, but it's their intelligent forecast based on the information they have. What it's showing is if you look at products based around software, so as opposed to hardware, so services that are based on software, the growth in terms of that area will have, now I'll try and get this right, compound average growth rate, I think, yeah, is going to be 11%. So year on year, they're estimating that the software services world is going to be growing at about 11%. These numbers are billions. So we're going from 206 billion now to about $500 billion in 2017. Now again, this is a forecast, so who knows? So why do I give you all this information? Well, what's interesting is the difference between what goes on, say, in the States and what goes on in the UK. There's a reason why in the States there is Microsoft and Google and Intel and da-da-da-da-da, and in the UK there isn't. I mean, the one example in the UK that is renowned the world over is probably ARM, but that's possibly the only one I can think of at the moment. Here's a case study that's interesting. If we look at UML, which you in this room will all be familiar with. Nowadays, it's everywhere. It's used in all IT industries in terms of specifying systems. It's particularly used in companies where they've outsourced a lot of their development to places like China and India because it's the lingua franca that enables them to actually talk to other countries and manage what they're doing in IT projects. Years and years ago, when this area started to get traction, it was entirely US driven. What's interesting is that in Europe, my personal opinion is that European academics were initially really very dismissive of UML, and it took years and years for them to realise that they might be being rather dismissive of that, but actually industry was going for it was completely engrossed with UML and was using it everywhere. It was becoming ubiquitous. Now Europe is slowly catching up, but essentially it's too late, because that space in terms of the business world is completely owned by the likes of IBM and Microsoft. We do not want to repeat that. The next wave of things which may be coming is something like this, and I've tried to summarise some ideas that came out of a different Forrester research report. At the moment, companies have all sorts of software that help them build and maintain their business processes, and which help them to try and understand trends in markets. They have a lot of real-time data that's starting to appear. So with the existing kind of IT technology they've got, they can, by hand, put together business processes that can support what's going on day to day in their company. And they can try and understand trends in a statistical way. However, what they want are, I mean, it says on here automated solutions, but in reality it was semi-automated solutions. They want the machines, the computers and the software to help them optimize their return on investment, to actually work out what to do. By that I don't mean statistical trends of what may or may not happen. They want to have specific actions that they can do within their own business that will affect what's going on within their own business based on the real-time data that they're going to be getting from their market and their industry. They want support in automatically constructing new business workflows that enable them to optimize what's going on in their company, or possibly even work on new business opportunities. That's an area that's going to be very exciting over the next few years. But will it be the same as UML? Will it become something that the Americans are very good at and the UK isn't? So this represents my personal opinion about the state that we're in terms of the academic industry interface. If you spend time working in industry with an academic background, you soon realise that what goes on in business, and I'm specifically talking about business rather than industry, so I don't mean necessarily working with Intel or Microsoft or IBM. It's obvious that what they do is very hard and difficult and challenging. But I'm sure that if you went and worked for Tesco's with an IT manager day in, day out for a couple of years, you would discover the same thing. What the businesses are trying to do with IT, from a computing point of view is hard, it's theoretically interesting, and it's extremely stimulating intellectually. What's more, if you're a very, very clever person in terms of computing and you come up with a really smart idea, your smart idea from a software point of view can be turned into a product in a matter of months as opposed to years, which is quite a surprise when you talk to people, say, from a physics background, where they think if you do a fundamental breakthrough of physics, then in 30 years from now it might get turned into a new light bulb or a new television set or something like that. But if you look at the literature, say, in theoretical computer science, a lot of the work there isn't about this stuff. No, the work that is done in theoretical computer science is extremely rich and deep and interesting, but it doesn't seem to be particularly relevant to this business community. Well, why on earth not? My personal opinion is that at the moment, too much of the academic community does not yet have a deep understanding of the business culture. One of the reasons for that is if you are an academic and you leave academia to go and work in industry, chances are you're never going to come back, because we are currently in a publish or perish environment where industrial experience isn't valued, but a large pile of research publications is. Now, research publications are extremely important and valuable, but that does not mean that industrial experience isn't. So that gives you some of the background of the issues, particularly the issues around the interface between university and business, which is something that the BCS Academy will be trying to address. I think a lot of the problems are down to culture, and that's exactly an area where a learned society can be of most benefit. So what are we going to try and do in the BCS, in the Academy of Computing? As I mentioned earlier, we are only just becoming established, so the activities are things that we want to do, they are not things that are yet happening. Well, what's the point of any of the activities that we would like to be able to do? What we want to do for people who become members of the BCS Academy is to provide them with access and influence. Access to resources that will help them in their jobs and with their careers, and influence in terms of shaping what goes on between business and academia. That means influence with government when they consult the wider community about what they should be doing. It also means influence with funding bodies when they ask the wider community what should be going on. And it means specifically influence over that interface between universities and business. For this particular audience, I think the most important thing of what do we want to achieve in 5 years' time is this one. That when people start on a PhD in computing, it's just automatic that they will join the BCS Academy. That's where I hope we are in 5 years' time. Before this meeting started, I mentioned that I did my own PhD in pure mathematics. It was absolutely the norm that when you started a PhD in pure mathematics, you signed up to the LMS, the London Mathematical Society, and all PhD students did that. And it wasn't because the university mandated that you must do so because otherwise you wouldn't be seen as a professional mathematician. You did it because you wanted to show that you were part of the mathematical community and that you wanted to talk to other people in that academic community, and the best way of doing that was to be in the LMS. And I want the BCS Academy of Computing to play the same role. So as I say, we are starting. We don't have specific services that you can sign up for at the moment. And we're consulting as much as we can with people, such as yourselves, about what sort of services would be the best ones to have. We do think that any service that we do create should be for a good reason, and here are the good reasons. It's about creating a cohesive community. So any service, any activity that we start should foster more cohesion between the different groups. A service should be there because it stimulates new interactions between different communities, the business community, the researchers, the people in schools. But I've put here suppliers stroke developers. So here we have businesses which might mean users of IT. Here, suppliers, developers, these are the people that create the new technology in collaboration with the researchers. So it's all of the different parts of the knowledge supply chain. And a service or an activity that we get involved in or sponsor or start for ourselves should, as one of its main aims, be about building long-term relationships not just a brief interaction where people meet, go off and never talk to each other again. And I think I'll stop there because I've overshot my time as it is. But are there any questions?